So modeling with design intent, a very modern term. Few people actually understand what it means. A lot of us are actually doing that during their day-to-day working life without even knowing that they're following this rule. And this shiny model on the right, I did specially for this presentation. What the modeling with design intent means that your model is structured, defined, and adaptive. I think this we can all understand, right? So now I have a question and you can answer in the chat. What do you prefer to see when you're working in SolidWorks? The left one, which is 1, or the right one, which is 2? Yeah, I do believe so. 2 is the better one. So what you will learn today is to make model definition. You will learn how to improve your design structure, and you will learn some tricks about design evaluation. And now a little bit about me. If you don't know me, I'm Danute Petrova-Nikolova, also known as Dani, SolidWorks power user, certified expert, the champion of the year. I work as mechanical design engineer, and I have 10 years experience in electronic measurement industry, more precisely in automotive, electrical vehicles, space, data transfer, renewable energy storage. I'm also a content creator. I have my own YouTube channel, which is for SolidWorks, and I think there you can learn also a lot of things. I will share now the links in the chat so you can have them. So my YouTube channel, my LinkedIn profile, and my website. My website is not impressive at all. It's just there to have everything on one place. But if you reach out in LinkedIn, I'm always glad to help when somebody has questions. Now, first step is about definition, or when more is less. In the past years, a lot of, I would say, fake gurus are promoting to have a more simplified feature tree, to have less and less there. From one side, that's good, but only if you're removing unnecessary operation. From the other side, if you make it too simple, you're actually making your model worse. There are few things that you can use. There will be additional features, of course, in your design tree, but they will help to your model to be well-defined, easy to navigate, and easy to change. And these are the sketch picture, the guide sketch, and the reference geometry. You have them here pointed out in the picture. And on a purpose, I decided to use one of the Model Mania models, because Model Mania is also promoting modeling with design intent, and it's a nice model as a sample. When we are defining our model, we have first the global modeling definitions. These are the sketch picture. What is actually a sketch picture? This is a sketch in which you give a lot of information about your model. You can draw almost everything there, but you do not use this sketch for any feature. So you don't make directly from it boss extrude or cut extrude or anything else. It just stays there on top of your tree as a sketch, from which later you can call different contours. No, not the sketch picture. Sorry, this was the guide sketch definition. The sketch picture is you import a picture and you can see there are different things. Then you have the reference geometry. This can be plane, axis, point, or coordinate system. They're more or less self-explanatory. A bit later when I show the model, we will see how these are working together. Advanced model definition, these are custom properties, configuration table, design table, global variable, and equation. This advanced one is better to stay away from them if you are making more simple models, but they are a must if you're making a complex model with a lot of features. custom properties, of course, they apply for every type of model you're doing. Maybe the most often use I have is things that should be in my drawings. I put them in custom properties and then I call them up directly in the drawing later. So I'm sure I didn't mistype the name or the description or the part number of the part I have. In design definitions, these are the relations that we have. It's good to use fully defined sketches. It's easy to see when somewhere is missing definition, is sitting blue. When something is defined, it's in black. If you're not sure what is not defined in your sketch, you have this tool, which is on the screen, is a screenshot, which is fully defined sketch. I would not advise you to use this feature before you place the important definitions for you, because it's, let's say it is defining in a strange way. Better put your definitions first, then if you're missing something, use the tool so you can fully define your sketches. Then for the features, these are the start end conditions, guide curves, and center lines. So why actually we need all of this? Let's go to SolidWorks. Do you see my SolidWorks, or it's still the presentation of the slideshow?
It's still showing slide.
It's a slide. Okay. It seems I have to switch between the two. So we'll start sharing again. Okay, let's try it like this. Now you see SolidWorks. No.
Sure. No.
Ah, you know why? Because I'm moving the zoom and it's going with the zoom on this. No. Okay, that's weird. This is supposed to be screen 1 and it's screen 2. So now you see SolidWorks.
Yes, we do.
Okay, you see SolidWorks, and that's the model from Model Mania. Okay, now in the first sketch, I have placed the sketch picture, which is actually the...
Just a minute, Dani. Nitish, can you please mute yourself?
I muted him. So, yeah. In the first picture, I put the drawing that is coming for Model Mania. Why? When I have it like this, I can always have a look on the sizes without switching different screens. And also, not to disturb my model too much, I put a transparency to this picture. So I can see through it and see my lines of my model. Then I start with the guide sketch on the top. And as you can see, it's fully defined. But if I put something inside, like this circle, which is not fully defined, I will be able to call up the fully defined sketch, and it will define it for me. This is what I mean when I said that it's doing it a bit weird. It's ordinate always, and in some cases it won't be what you need. That's why it's better just to place your dimensions first and then go further. And as you can see, this guide sketch, we'll have this one. Nothing is extruded from it. Nothing is cut from it. Every time when I need to call out some of the contours, I'm making a new sketch and using convert. Why? This is something which I didn't know actually up to a few weeks ago, but I was doing anyway because it's more comfortable for me to work like this. But it turns out if you try to extrude just with certain contours directly from the guiding sketch, it's harder for SolidWorks to rebuild afterwards. And if you create a new sketch and convert the entities that you need, the rebuild time will be much shorter. So don't use one sketch, better use this sketch just as a guide and convert entities in new sketches. This will guarantee faster rebuild time. And also I have here a site guide sketch. And here I have also the definition, which is the outer plane. Why? This part here is extrude from here to there, but is dependent on the outer ring. So what I did is actually I create an outer plane with this point and perpendicular to this line. Why I didn't make it just a distance or coincident to this point? Because I want to have the capability when I change this angle, everything to change with that without breaking my model. If I make it just parallel to the, I don't know which one is this, to the right one, and coincident here to a point, then I will receive an error when I try to do that. Oops, let's go back to 90 degrees. And of course, I can move it also in the other direction if I want. Anywhere. And as you can see, everything is staying as it should be. This is what means a robust model, stable model, and one of the reasons to model with design intent. So now we are switching again to the presentation. And you see the presentation. That's good.
Yes.
Okay. So now I have decided to put inside one of my models for work. Very few people have seen my work, which is for work, not the fun part. These are measuring devices for electrical vehicles, and yeah, they have their own challenges, no matter that they look simple. And this is because of the clicking mechanism on the top. The tolerances are so tight that even the thickness of the anodizing is defined. So now I have a question. Can you guess where is the origin of the front panel and why is it there? I will start with you, Prasad. Can you guess?
Well, you want me to guess where's the origin of the front panel?
Yes.
I would go with at the edge, like the left bottom edge.
Yes, left bottom edge. And why it should be there?
Well, if I choose mid plane, I mean, if I'm choosing the center, right center, the center of the rectangle, you know, I cannot adjust it according to the planes. Like I'll always have this two planes coinciding. I mean, what's that? Two plane intersecting at that at the center, and I don't want that in my design. Basically, generally, not all the time, but generally, I wouldn't want that. And another reason would be because there is pattern, and it's easier to pattern your the what I'm seeing here, the cable connections. If everything is in one side of the pattern, I can easily pattern it. If they are split into two planes, obviously I'll have to go with the direction 1 and direction 2. I don't want to mess up with with that again. So I guess that's my reason.
Okay, you give a good reason, but to be honest, I was misleading a little bit with this question, and I will tell you now why. Okay. I'm asking you this question, but you don't have enough information. That's the truth to give me the origin of this part. You guessed it correctly. The origin is in the bottom left corner, but usually if you are following just the design logic, it should be in the middle left, because the middle left is the middle are the connectors. And when you have something symmetrical top and bottom, it's good to be on the origin. That's the design logic to have the origin. In this case, however, the origin is the bottom corner, not in the middle, not because it's easier to design like this, but because it's relevant to all the models which are inside this assembly. This assembly is a combination of mechanical parts and a lot of boards, and all the things should have exactly the same origin point. So it's not just the front plate and the housing that are made with the same origin. It's also the boards inside. Because if the connector is on the wrong position on the board inside, it won't fit on the front, or the board won't fit in the housing. And that's one of the tricks of the modeling with design intent. You should know what your model have to do to define it correctly. In my case, when I was building this one, I knew it has boards inside and that we must keep the same origin for everything, so I can give not only the correct position for the connectors, we're using in this case Co-Designer. So I'm working directly in SolidWorks and positioning the connectors for the electronic boards. But in other cases, you must give coordinates to the electronic engineering department, and they will know where to place the connectors. And the only way to ensure that everything is correct when you don't have this collaboration between the softwares is if you define one origin for everything. So are you surprised with the answer now, Prasad?
Yeah, I was really surprised, because I missed out on a lot of things. I didn't even touch the surface, but yeah, that clearly makes sense now.
Yeah, that's why one of the most important things is when you're designing is to have all the information.
Yes.
Okay, other people
definitely.
are coming. So, and now we're going to the design structure. When you start building, you should always follow the simple rule. First, you add the material, then you remove the material, and at the end, you add finishing touches like fillets, chamfers, and such things. Why? Because to avoid having mistakes in the model, more or less, to say it like this. And now we will go back to my SolidWorks. Do you see the SolidWorks now?
Yes. Yes.
Okay. And also part of the structure is, if you have a look here on the left, I have placed the different features in their own folders, which are add material, remove material, and finishes. When I do this for work, I also use the folder structure to keep everything ordered, like the panel you said. So it has many different configurations. So first I have a folder which is the base panel. After that, I have a folder which is cut out for the connectors. After that, I have another folder which is for the plating. And then I have a folder for engraving, because this panel has a lot of steps. But in case with something more simple like this, I'm just putting different folders which are add material, remove material, and finishes. And now we will go step by step. First, I do this part here. Then this part here. These two can be not in the opposite order. It's not a problem. But what will happen if I don't make this extrude like this, but already implement the inner cut? You see, I have this extra material here, which is a problem. In this case, I can see it because the part is small. There are little features inside. But when you're working on something more complex, or you have really a small protrusion through the other part, you will miss it, and this will make a part not manufacturable. That's why you're going with the steps add, remove, and finishes. Does it make sense? Prasad, you're my person now.
Yes, it totally makes sense, because sometimes I also have the same problem. I mean, not generally, but sometimes I won't be in the presence of mind, and then I'll design it, and later I realize, okay, I did something wrong, and now I have to do an extra cut or an extra extrude to remove whatever that has been done. But yeah, this makes total sense.
And here, as you can see, I didn't rename the sketches. I put names, however, on the different features that I did, but every sketch is just converted entity of the base sketches that I have.
Yeah.
And the rebuild time is really, really fast. Even if I go more complex here, add more features, it will still be fast to rebuild. Now we are going to the remove material. Of course, here you can, on the remove material, you can go in the order you want, unless in some cases you have to make cutoff to surface or something like this, then you should be more careful which is first. But I'm making the cutouts first, and then I'm making the drilling. And the last, of course, are the finishes, which are 2 steps of fillets. And there are 2 steps of fillets because this one and this one here on this edge, you cannot make at once. Just small tip, sometimes when your fillet is failing, it could be because something like this. Okay. And we are going back to the presentation. But actually, do you have some questions so far? We were through two chapters already. So if somebody has some questions, please share them. I will try to see them somehow.
I don't. It's not a question, but I've seen many people do this. As soon as they think that they need to apply the fillet somewhere, they'll just do it right away. They like generally what everyone does is they apply the fillet at the end of your design. Like that is like I mean, it's better to give fillets at the end of your design. But what I've seen is some people will, like I said, they'll, as soon as the feature is done, they'll apply the fillets right away, and then they struggle to edit their parts afterwards. So what suggestion would you give why people should always, give the fillets or drafts at the end of your design, of the design?
Yeah, that's a really good question, and I will answer in 2 different ways. One is the one I'm showing here with the simple model and the finishing fillets, but sometimes you have the fillets which are for machining. When we have a machined part and we have a cavity inside, we must have a fillet on every corner. I would advise when you have such cutouts, you use the shape without the fillets. And after the cut, you apply the fillets in the corners. But these are technical fillets, the ones you need for the part to be done. Because the next steps of your modeling will be dependent on these fillets, and they should be there. Then you have these design fillets, which are more for finishing purpose. And these ones you put definitely always at the end. And the reason for that is, first, for rebuild, it's faster. Fillet is requiring more calculation, and actually feature after fillet is requiring more calculation. And this is confusing a lot your mates. When you're making relations to a fillet, you remove the fillet and everything is breaking afterwards. So you have to avoid that. The reason number 2 is if you decide to 3D print this part and to export as STL, when you have a fillet has tons of triangles inside, and in the same time it's really hard to print. So for 3D printed part, you would like to suppress the fillets and then save the STL and print it. And if the fillets are not at the end, you won't be able to do that, because you probably already placed relations to that fillet, and when you suppress it, you suppress also features. Is this answering your question?
Yeah, totally. I think it will help many of the people here, and also who will be watching the recording, because I always suggest that if you are adding a design fillet, please do it at the end, because again, if you suppress one thing, the rest of the design is going to mess up badly. But this explanation was really great. The machining fillets, why it should be added, and also the design, the finishing fillets, why it should be added at the end. We have one question from Abhishek. He wants to ask how you created the cut in the middle.
And the question is, does he mean this cut here?
Yeah, okay. I'm guessing the first cut, not the circular cut, but yeah, that.
Yeah, this one. That's a good question. In this particular case, I made a boss extrude first with the cut directly inside. And then I made the other boss extrude. That's fast and easy way to do it. But if you prefer to make this cut also as additional one, I will just very quickly show you how to do that. Now, if it's like this and you would like to add the cut here in the remove material area, first, you'll have to start from the outer plane sketch, the one which I defined to be for my outer plane. Let's say it like this. We start here with a sketch, but I want it from the other side. Then I will show my side sketch to have the correct sizes here. And we'll convert these entities. And then I will cut to this face, but very often you will receive a funny result if you start directly from a tangent face. So the trick here and the work around is when you start the extruded cut is you're not starting from the sketch plane, but give some offset. And then you say up to surface and choose not this one, the inner one. Let's see if it will work. Yes. For some reason, it's not showing me the preview, and it must, but, and this is how you make this kind of a cut. If you start directly from the tangent surface, it may get confused. So to make it cut like this, give some offset and cut up to the cylinder, and it will work out. Does it make sense?
Yeah, it totally makes sense.
Okay. So I will return my model to its previous state. So good. Then we can go on with the next steps. Yes, design structure you saw already. Here I'm giving a screenshot from the front panel that I asked earlier about. As I said there, I have the base front plate. And in this case, you have all the steps first done for the base front plate. The reason is because this is the base for every other design. And this part only is one complete design and everything else comes afterwards. It's the bit tricky part to decide which comes where in this case, because I said, okay, you build first the material, you add it, then you cut it, and then you add the finishes. But when you have something more complex, maybe you have to repeat these steps one after another in few different folders, like in my case. Because here, like every folder is like individual design. And the example for this thing is I was able to take out some of the information. This front plate has 63 features, 24 configurations, and it's rebuilding just for 1.2 seconds. This is what modeling with Design Intent really gives you. Not only no errors, but also the stability of your models. Yes, plus that. I have more extreme than that, but I decided to give a part as example. So, oops. And I will wait for the design evaluation for a little bit. We will go back to SolidWorks. And as I said, in Model Mania, you should build this model first. Then you receive another task, which is to modify this part. And the easiest way is if you build your model fast, but still clever enough, so you can just modify on the go. Oops, this one is here. And your model still keeps rebuilding correctly. The other thing that this gives you is you can add later a design table, add inside the sizes from your base sketch, and you can make different versions of this particular model just in minutes without building every single instance new. That's the part which means that your model should be adaptive. Not only to be able to change it without damaging everything, but also to be able to change to make different versions in one. And if we go back to my front panel, which maybe I will just show again. So this front panel, as already mentioned, has 24 different configurations. But the cutouts which are here for the different connectors, every type of connector has its own cutout. And when my customer says, I want to make a new front with this and this connector, 2 pieces, for example, and this connector, 4 pieces, I can make it just in a few minutes instead of modeling completely new front panel. And everything stay in the same file, and the customer is happy too. I do show off, Eric. So, and now the final part, really a bit underestimated, that's the design evaluation. You cannot tell that your design is fulfilling the requirements if you haven't tested it. So we have many different tools in SolidWorks that can help us test. One is mass properties. With mass properties, you can see a lot of information for your model, and mass properties is something that everybody must know how to call and to use. You can see the center of mass, you can see the mass, the density, the surface area, and many other things, but more or less this first area is what is important in many cases. And here is example, if you remember my chomper, this toy that I did from Plants vs. Zombies. I don't know if you know it or not, I didn't prepare a picture, but chomper wouldn't be able to stay if I haven't calculated very precisely where to be its center of mass, because it has a huge head and very small base, and if the center of mass is not on the correct place, it will just tip over. So then we have what we have. Measure. Okay, measure, probably many of you know. You can check the sizes, the outer sizes, many things. Interference detection, this is something very important for assemblies, to check if every part, every feature is on the correct place and you don't have interference. Geometry analysis is actually a very interesting evaluation tool. Now we will go back here. So it will make a calculation based on what you have defined. I just left the defaults, and it will say if you have too small faces, if you have short edges, if you have too sharp edges, or discontinued face, very important things that it's better to check before you send this for machining or manufacture. To be honest, very often I forget also to run this one, and I have a case once. I remember once I had a case that the manufacturer sent back information that I have a protruding face and actually the model cannot be done like this, and I needed to redo it. When you're working with complex model, it's really easy to miss something like this, so it's better to run such a check and to see if everything is okay. Now, symmetry check is important only if you must have symmetry, and it's a good, fast way to prove your model is okay. And we can check this too on this model. That's why I choose this model to show off today. And remember, Prasad, when I told you earlier, when you have a symmetrical model, one of the places should be in the middle.
Yeah, I remember that. And I'll remember that forever.
And here we run the symmetry check for on the top plane. And as you can see, it's perfectly symmetric. Nothing is failing. So, and the next one is what we have. Thickness analysis. One of my favorite tools for check, especially if you're 3D printing. In the past, I really often made a mistake to send something to the printer and to have a wall which is less than 0.5 millimeter thick, and such thin wall cannot print. And at the end, you see on the printer one failed print, and it's like, oh, I forget to check this again. You go to SolidWorks, you run the thickness analysis, and you see, yes, you have a too thin wall. And that's why that's also a great tool, and you need it. I mean, it's a must check all the time. Draft analysis is something you need for casting mostly, and injection molding, to check if you have everywhere the draft angles. Undercut analysis, this is also for machining. Sometimes if you're on 3-axis CNC and not on 5-axis, it's good to check this one too. Clearance verification is mostly for assemblies. It's also a very good tool, and the whole alignment, very important tool too. So yeah, more or less, that's all. If you want to see some other training resources for drafting and for modeling, there are 2 great tutorials in SolidWorks network.